Hello class, my name is Fajano Lolade Peter. This is lab 3 on Karnaugh maps. So the objective of this lab is to design and implement circuits and to simplify Karnaugh maps. So equipment used in this lab, we used our wires, we used our breadboard, we used uh, we used our battery, we use our IC gates, yeah, and I also use some tape to be able to measure my to be able to know where my inputs are A, B, C, D because I have a lot of wires on this circuit on this board. So introduction to Karnaugh maps. Karnaugh maps or K maps for short provide another means of simplifying and optimizing logical expressions. This is this is a graphical technique that utilizes a sum of product form and a product of sum form, which is also known as mini terms and max terms. So for the procedure, I have my data given to me by my professor telling me which numbers I should use for my Karnaugh maps. So I have F A B C D is of mini terms is 0, 4, 6, 10, 12, 14. So I drew my table. After drawing my table, I put in my inputs around it and labeled my table. So where for the mini term, when A is equal to 0, A is going to be A prime. And when A is equal to 1, A is going to be A. So I put everything in my table and get my sum of products, also known as my mini term. And also I did this so for the max term, so everywhere that doesn't have 1 in the mini term, we put them as 0 for the max term and find the product of sum for the max term. So for the max term where A is equal to 0, A is going to be A, and where A is equal to 1, A is going to be A prime. So moving forward, I sketched out my circuit on a paper before going to multisim. I'm going to go to multisim in a few. So I sketched out my circuits. We know that when you are multiplying, you're gonna have an AND gate. When you are adding, you're gonna have an OR gate, and when you see a prime, you have a NOT gate. So using that I was able to sketch out my circuits for the mini term and also for the max term. Also, I was also able to draw a truth table. So after drawing the truth table, I realized that the mini term and the max term both have the same results for the truth table, which is true, which is what we should expect also in our circuit. So using this process, I first had to know the pinouts. So I first had to know the pinout that I need to use. This is pinout for 3 input AND gate. Yeah, this is the pinout for a 3 input AND gate. And we have the pinout for the NOT gate, pinout for the AND gate, and pinout for the OR gate. So After that, we move forward to putting it on our multi-sim. This is my multi-sim right here. I was able to draw my circuits on my multi-sim. This is my mini terms, and I also see right here that the truth table have the same results. And also this is for my max time, which also shows me the same result. So which let me know that yeah, my max time is correct. My max time is correct, yes. So yeah, I'm skipping. This is the main time. So I'm gonna demonstrate my circuits right now. I'm also gonna have this truth table right here. So okay, so this is my mini time table. As you can see, all the inputs are out right now. They're not connected to anything right now, and I labeled my inputs. So turn it on, nothing is gonna happen because it's not connected. Okay, so for the first one we have A0, B0, C0, D0. So I'm gonna put everything to 0. So I made sure that my circuit is off. My circuit is off before putting in anything. So I have 0, 0, 0, and 0. So the light is supposed to come on. If the light didn't come on zeros when everything was 0, that means there's something wrong with my circuit, because that is what I have in my truth table. So the light came on. I'm gonna test for about 3-4 more. When A is equal to 0, B is 0, C is 0, and D is 1. So I'm gonna look through it. D, this is D right here. So I made sure it was off before switching. So D is 1. So D should be off. The light doesn't come on. So I'm gonna test for A is 0. I'm gonna test for A is 0. A is 0. B is 1. C is 0. D is 0. So just B is 1, right? I'm gonna look for B and place it at 1. What should we expect? We should expect the light to be on, which is true. The light came on. So I'm gonna test everything for all ones. When they are all ones, what should we have? The light should be off when they are all ones. Anything other than that, it's not correct. Yeah. So the lights remain off. So that is for my mini terms. For the max term, I also sketched my rough circuits on a piece of paper to know how my circuit should look like, and also I had to number it to know where it should go. So I had an issue with the max term at first, because I put the wrong IC where it shouldn't be. So the lights wasn't coming on, and I had to restart the whole thing. I did it about 3 times before I could get the correct result. So these are all my inputs, and I labeled them to know which is which. So as usual, I'm gonna keep it off while I'm changing. I'm going to keep it off while I'm changing my inputs. Alright, so this is my truth table right here. I'm going to do about 3 to 4 or 5 to prove that this circuit is correct, and it's the same with the many terms. So we have A is 0, B is 0, C is 0, D is 0. So what we should expect is that the lights should come on. Anything other than that means it is wrong. So the lights came on because that is when A, B, C, and D is 0, the output will be 1. So let's test for 0 0 0 1. That means when A is 0, B is 0, C is 0, and D is 1. So A 0, B 0, C is 0, and D is 1. The light should be off, and the light is off, and turn back off. Okay, so I'm going to try for 0 1 1 0. The output should be on, so 0 1 1 0. Zero, 1 1 0. The light should be on. Yeah. I'm also going to test for 1 1 1 1 1 1 0. The light should also be on. 1 1 1, excuse me, 1 and 0. The light should be on because that's our output. And finally, I'm going to test for 1 1 1 1 when all the outputs are on. When all the inputs are on, we should get the output should be off, so the light is off. So this proves that the Karnaugh this proves that the max term and the mini terms are both the same. So the result we got, we were able to verify that both these tables are the same. The sum of products is equal to the product of sum, which also means the mini term is equal to the max term. In conclusion, I was able to verify my circuits. The mini term circuit and the max term circuit came out the same as we saw in the demonstration. And also I was able to understand how K-maps works, because I verified that my midterm circuit and max term circuit turned out to be the same. So, which is why I did 2 different circuits, which is the midterm and the max term, and I demonstrated both of them to show that they were the same. Thank you very much.